Welcome back to another video. As you can see from the title, we're going to be looking at integration by substitution, by U-substitution. Okay, so let's just get right into it. Now, usually when we have some types of complex integrals, we need to make a substitution in order to simplify the integrand so that the problem can be solved easier, right? Now with some problems you may be able to see what's happening with the integral in order to come up with an answer, but not in all cases, because if I should write a problem like this, oh, that's a funny looking integral sign. Right, let's say we had 2x times x squared plus 4, right, and that's raised to some power, let's say the 6th power dx. Great. Now we might look at this and we say, okay, based on what we know from differentiation, if we should differentiate x squared plus 4 raised to the 6th power, okay, let's say we had that and we're supposed to differentiate this. Okay, so let's just put y equal to that. Okay, if we were to differentiate this, then we would get six times 2x multiplied by x squared sorry, I should have put a 7 there, my bad. Good. And okay, great. So this would be plus 4 to the 6th, right? So in our minds we can visualize that and say, okay, then this integrand must be coming from this in the bracket, x squared plus 4 raised to the 7th power. It must be coming from some multiple of that, or a fraction of it, or whatever, right? So looking at this, we can see that what we get here for the derivative of y with respect to x is 7 times what's here for the integrand. So we could say that the integral of this 2x times x squared plus 4 raised to the 6th power, we could say that it is 1 over 7, since what we have here is 7 times what we have there. We could say it is 1 over 7 times x squared plus 4 raised to the 7th power, and of course you would have your plus c, because if we should differentiate this and get that, then obviously this is the integral of this integrand here, right? Okay, so that's what I meant when I say that we could look at it and sort of visualize where it's coming from and find the integral. Now let's use substitution to solve this by looking at it from a different angle. Alright, cool. So, well, why is my pen still lagging? Alright, so let's say we are using the substitution method, right? So first we need to choose an appropriate substitution so that we can get rid of our x's like temporarily in order to allow the problem to become simpler, right? So if we should let 2x be equal to u, let's say we let u equal 2x, right? Therefore we would replace the 2x here with a u, right? We can see that there is going to be a problem because we wouldn't have anything to replace what's in the brackets. So therefore we would have a mixture of u and x, and even if we should differentiate u with respect to x, we would just get 2, which is a constant, which would not cancel anything. So therefore the appropriate substitution to make here would to let u equal to x squared plus 4, because we would replace x squared plus 4 with u, replace that with u, and also now we would need to replace 2x and dx. But if we look here, if we should differentiate u with respect to x, we realize that we get 2x, right? And being that we're changing the variable to u, we would need du. From here, if you find du, you realize that du is equal to 2x dx, right? Therefore we can just simply replace 2x dx with du, and in turn make the problem simpler. So 2x dx would be du, and we would replace what's in the bracket here for u. So we would have u to the 6th power, and we're integrating with respect to du, right? Since we switch it out for 2x dx. Now we would just integrate using the power rule, right? And when we integrate u to the 6th, that's simply u to the 7th power divided by 7, and of course you add your constant of integration, right? Now that we have that, all we need to do is just replace u with what we substituted for u, which was x squared plus 4. So therefore our integral, you can see that our integral of 2x times x squared, well, it's up here already, let's just use up here, 2x times x squared plus 4 all raised to the 6th power times dx is simply equal to x squared, wow, x squared plus 4 all raised to the 7th power over 7 plus c. Good. And that is one problem down. I'm going to try and cover a couple problems so that you can have better understanding and a better appreciation. Right, so let's just dive into another problem here. Let's say we had to find the integral of cos cubed x dx. Good. Now looking at this, we would wonder what substitution we would have to make. Now some questions, depending on where they're taken from, might tell you what to use as your substitution, whereas others may not. So having a good amount of practice will help you in this regard. So for this problem, we're going to let u equal to sine x, and let's just go ahead and find du from now. So du would be equal to cos x dx. Okay, now let's head back to our problem here. So what we can do, based on how the problem is set up and the substitution that we made, and given what du is, we can say that, okay, let's rewrite cos cubed x as cos squared x times cos x dx. Right? Already you can kind of see where I'm getting at with cos x dx. And if we can recall this identity, let me just write it here in yellow. Well, that wasn't yellow. Anywho, cos squared x be equal to 1 minus sine squared x, right? Because we would want to do this, since we are letting u equal to sine x, we'd want to replace what is here with something containing sine, so that we can completely replace the x's with u's, right? So therefore, if we rewrite cos squared x as 1 minus sine squared x multiplied by that. Now let's come back here where we have u equals sine x. We can see that sine squared x would be equal to u squared. That is, if we square both sides. So therefore, we would have the integral of 1 minus u squared right, and then cos x dx would simply be du. Great. Now all we need to do is integrate with respect to u, and that would simply be u minus u cubed over 3 plus a constant. Then we would simply just substitute u for sine x. So therefore the integral of cos cubed x dx is equal to sine x minus sine cubed x over 3 plus c. Good. And this was actually a good problem. Let's do another question. Right, so let's look at this problem here. It is similar. We have sine x Wow. The pen is lagging, making my bad handwriting look worse. Okay, and for this problem we're going to let u equal to cos x. Okay, now, and of course you can see where this is heading. Let's just find du immediately. So du would be negative sine x dx, right? Therefore all we would need to do is just replace sine x dx with let me just do this here. So sine x dx would be equal to negative du we would divide both sides by -1, right? So all we would need to do is replace cos to the 7th x with u to the 7th and sin x dx with negative du, meaning -1 times the integral. Right, now the integral of u to the 7 would simply be u to the 8 over 8, and remember that there is a negative sign outside the integral sign, so you'd have a negative sign there, and of course plus c. Right, and now all you would need to do is back substitute. That's right. So therefore the integral of sin x cos to the 7th x dx would be equal to negative cos to the 8th x upon 8 plus c. Good, and that's it. Problem solved. Let's just jump into another question. After you do a bunch of these, then eventually you would have a general feel for doing these types of problems. Okay, so this looks like a nice problem here. Integral of 1 over 1 plus x squared dx. For this problem, it actually tells you to use the substitution x equal tan u. Right, as I said before, depending on what you're doing, some problems might give you what substitution to use, others may not. And of course, if you just see a one-off problem, then more than likely you will not be told what substitution to use. So get a good amount of practice in so that you have a feel for these types of questions. Okay, so now if we find dx du, that would be equal to sec squared u. Therefore dx would be equal to sec squared u du, right? And of course let's do this here. So we would have 1 upon, and remember that x is equal to tan u, so this would just be 1 plus tan squared u and dx is sec squared u du, so therefore it'd be multiplying by a sec squared u du. Now let me just make mention of an identity that you should know in order to solve this problem, and that identity is 1 plus tan squared u is equal to well, let me just use something general. 1 plus tan squared a is equal to sec squared a. Now we'll just apply this identity to this problem. So therefore our denominator would become, so let's just it's sec squared u. Here our denominator would become sec squared u based on the identity. Good. Now sec squared u divided by sec squared u, that's simply 1. Come on, pen, stop lagging, please. Oh. Okay. So that's simply the integral of 1 with respect to u. Therefore, that's just equal to u plus c, right? And based on our substitution up here, we let x equal to tan u. Therefore, from that we get u is equal to the tan inverse of x. So coming back down here, we can say that the integral of 1 over 1 plus x squared dx is equal to the tan inverse of x plus c. Right? Good. And this is this problem, the integral of 1 over 1 plus x squared. That's something that you should know, I guess, that it's tan inverse of x. But it's good to do it by substitution. Alright, so let's just do more problems. Let's see. Let's go back to a simpler looking problem. Good, and that's raised to the 8th power dx. Great. Now, looking at this, it's similar but not the same as our first problem, because in our first problem we said that, okay, based on what we did before, we would let u equal to x minus 2, and if we found du dx, we would get 1, therefore du would equal to dx. And we look at this and say, well, okay, we don't have an x dx here, so how are we going to switch out the x dx? Now, here, if we look here, we can see that u is actually equal to, well, not u, x is actually equal to u plus 2, right? So therefore we could switch out the x here for u plus 2, and or x minus 2 for u, and dx would just be du. Therefore, when we rewrite this, we would have u plus 2 in brackets multiplied by u to the 8th power du. Good. Therefore, all we would need to do now is distribute this u to the 8 across the brackets, and we would get u to the 9th power plus 2u to the 8th power du, and this is now a simple integral, so therefore our answer would be u to the 10th power divided by 10 plus 2u to the 9th power over 9 plus c. Therefore the integral of x bracket x minus 2 to the 8 dx simply be x minus 2 to the 10th power divided by 10 plus 2 over 9 times x minus 2 to the 9th power plus c. Great. And we have covered a few problems. Let me just do one more before I end the video. By the way, thank you for bringing me to over 120 subscribers now. I appreciate it, guys. Please continue to share the videos and watch the videos. So for our next problem, we are going to do this one here, integral of 3x squared e to the x cubed power dx. Good. Now, looking at this problem, you might say, okay, what if we let u equal to x squared, right? Then du dx would be 2x. Now looking at that, if we should use that substitution, we wouldn't be able to completely get rid of the x, right? So therefore the appropriate substitution to use would be to let u equal x cubed, because if we differentiate x cubed, we would get 3x squared, and du would simply be 3x squared dx, right? Now we can see that that tidies up this problem, and we would just have e to the u du, because 3x squared dx would just be substituted for du. Now the integral of e to the u is simply e to the u. Therefore we can say that the integral of 3x squared e to the x cubed dx is simply equal to e to the x cubed. Of course, remember your plus c. This is an indefinite integral, so always remember to put your plus c, right? And I'm going to end the video here. Hopefully throughout the course of this video you have spotted some patterns, right? Take this problem for example. You realize that 3x squared is the derivative of x cubed, and naturally if you're multiplying e to some power by the derivative of that power, then the integral would simply be e to whatever the power is. Let me just write what I just said. So if you're integrating e to some function, let's use t. So if you're integrating e raised to some function multiplied by the derivative of that function, then the integral is simply e to said function, right? Plus whatever your constant is, use k in this case. Great. So that these are the types of patterns that you can look out for. So thanks for watching this video. Please like, comment, share, subscribe if you're new to the channel, and I'll see you in the next video.